Welcome students. Today we will solve some questions related to the fluid statics, especially the buoyancy, which appeared in the previous year GATE question paper. So the first problem which appeared in GATE 2003 Mechanical Engineering, which says a cylindrical body of cross-sectional area A, height h and density rho s is immersed to a depth small h in a liquid of density rho and tied to the bottom with a string, and the tension in this string is. So first of all we'll draw the problem definition. So this is like a cylinder is over there, or you can say container is over there, and in this container a body is having a height, a cross sectional area of A, and height total is h, and dipped up to a level of h. So up to this level this is been dipped. So this is your small h. Now up to this level everything is filled. Now it says that liquid density is rho and the solid density is rho s. And another important thing that this is connected with a string from the bottom. Now it asks that if what will be the tension in this string. So first of all we need to draw the free body diagram of this particular body. So the free body diagram will look like, if suppose its weight is, its mass is m, so mg force will be working downwards. Now one force is buoyancy, so buoyancy will work upwards, and another force is tension, so that in the tension in this string will work like this. So if this body is in equilibrium, we can write it straightforward that T plus mg is equal to buoyancy force. So now one by one we will find out the everything. So first of all we need to figure out the mass will be area multiplied by height will give you the volume, and then multiply by density of this one, and another thing is the buoyancy. So buoyancy force will be equal to the weight of the water which has displaced by the body. So body has displaced. Now this body overall height is h, however, sorry, this is capital H, however this is dipped up to a level of small h. So the water it has displaced is A into small h, that is the volume displaced by the body. Now so weight of the water drop displaced will be A into h into liquid density is rho, and then multiplied g, that will be the buoyancy force Fp. Now this is your equation 1. We need to put all these things and we will get it the final answer. So T is equal to Fb minus mg. So your Fp is capital A H rho into g minus m is your here, so A H into rho s into g. So this will be, you can take out only A and G outside, then this will be H into rho minus capital H into rho s. That will be the tension in the spring. Now your answer is D. That's your right answer. Now let's move to the another problem which appeared in GATE 2016 Mechanical Engineering paper. So this question says a large vessel shows in the figure contains oil and water. Oil and water a body is submerged at the interface of oil and water. So this is the interface, such that 40%, 45% of its volume is in the oil, while the rest in the water. The density of body we have to figure out. The specific gravity of oil is given as 0.7 and density of water is 1000. So we are not aware that how much. Now before solving this problem, the fundamentals we have to apply is, the fundamental we have to apply is that this body is floating. So if this is the body, so whatever is the weight that will be working over there, and this will be the buoyancy force. Now if both are equal, then body will be floating like the way it has been shown. So this is the fundamental we have to use. Now let's start. So it says that before this interface, here is the 45% and rest 55% is in the water. So we are not aware that how much volume of this body is there. So we are assuming that the total volume of body is, this is the volume of solid is Vs. Out of this one, 45% is here. So 0.45 Vs is in the oil. So 0.55 Vs is in the water. Now we have to figure out the buoyancy force in both two sections, and then we have to equilibrate with the total weight of the body. So in the first case, this is 0.45 into Vs is the volume of the solid which is in the oil, and this much volume, and then multiplied by the rho of oil, that will be the total mass, multiplied by the G will be the buoyancy force. Then 0.55 multiplied by Vs is the volume of solid, multiplied by rho of water, multiplied by G. That will be equal to the total volume of solid multiplied by the density of solid multiplied by G. So this is our equation 1. Now if you see that in all the equation this Vs is common, Vs is common, Vs is common, and similarly G we can also take out side. So if we revise this equation, this will look like 0.45 rho naught plus 0.55 rho W is equal to rho S. This is our equation 2. Now the specific density of the oil is given to us. So rho of water is equal to 0.7 times of rho of W. So that will be 700 kilogram per meter cube. So we can straightforward write 0.45 multiplied by 700 plus 0.55 multiplied by 1000 is equal to rho S. So this calculation will give the answer. So this will give the answer 865 kilogram per meter cube. Now that is your answer. So this problem appeared in GATE 1998. So let's start this problem, which says that a cylinder of mass 10 kg. So this is the cylinder, and area of cross section is 0.1 meter square, is tied down with a string in a vessel containing two liquids. So this is a spring through which it has been attached, containing two liquids as shown in figure 21. Calculate the gauge pressure on the cylinder bottom. So we have to figure out the gauge pressure at this location and tension in this particular string. So density of water is given, specific gravity of liquid A is given, and a specific gravity of the water that is known to us, that is 1. So this is liquid B, liquid A. So this is up to height this much, and this is up to height this much. So first we will find out the gauge pressure at this location. So we are aware that gauge pressure is additional pressure to the atmospheric pressure. So up to this location, this is your atmospheric pressure. So addition to this pressure up to this depth, pressure up to this depth will make the gauge pressure. Gauge pressure, gauge pressure at the cylinder's bottom. So we can mention this pressure as P. So this will be rho A HA plus rho B HB into G. So rho A is your 0.8 multiplied by 1000. Then HA was 0.1 meter plus rho B is 1 into 1000 multiplied by the height, which was 0.125, and multiplied by G. If you want to take G as 9.81, you can write over here. So the direct pressure that comes out to be 2011.05 pascals. So that is your gauge pressure P. So first part is solved. Let's move for the second part. In the second part, for the solution of problem, we have to draw the free body diagram of this particular body. So up to this level, this liquid is A, this is B. So what are the forces working? That is your M into G. Now this is attached with the string. So another force that is working in this direction is buoyancy force. However, this buoyancy force is due to the flotation of body in liquid A and liquid B. So that will be two part. So FB, force of buoyancy, will be due to liquid A plus liquid B. You need to remember this thing. Tension is working in this direction. So T. So we can write that T plus mg is equal to force of buoyancy. So let's quickly figure out. So we have to only figure out the FP because other things are given to us. So FP is rho of A into volume of A plus rho of B into volume of B multiplied by the G, that will be the buoyancy force. So we can rewrite this equation as rho A into HA plus rho B into HB, because the area because VA is equal to area into HA and VB is equal to area into HB. So we can take A outside and this G. Now we have to put the values. So rho is your 800.8 into 1000 multiplied by this is height, in submerged height is 0.1 plus water is 1000 multiplied by submerged height is 0.125 and then multiplied by area is given to us, that is 0.1 multiplied by 9.81. So if we calculate this total force, so this F buoyancy is coming out to be 201.1 Newton. Using this particular equation, the next thing we have to do is T is equal to FP minus mg. So that is your FP is 201.1 minus m, that is your 10 kg, and multiplied by G, that is your 9.81. So this value will be 201.1 minus 98.1. So answer will be coming out to be 103 Newton. So the answer is tension in this string is 103 Newton. If you have any confusion, you can drop me your confusion or any other problems in the comment section. I'll be happy to answer you. Thank you.